right, so the first thing you need to know if you're going to draw Lewis structures is that if you do the math real quick, if you get a 0, it means all single bonds, so you just add the dots. If you get -2, it's equal to 1 double bond. -4 is either going to be 2 double bonds or 1 triple bond, depending on what's going to make the molecule more symmetrical. So when we start, what's the first step? Total the number of valence electrons. So oxygen has 6, Br has 7 and 7. So my total number of valence electrons is going to be 20. So that's the first step. Step 2, I draw the skeleton structure. So I'm going to go O dot dot Br dot dot Br. How many valence electrons did I use? So 20 minus 4 is going to be 16 remaining electrons. So then I have to figure out how much everyone needs. When I go to do this, it's really the central atom I have to look at. Any outside atom except H is always going to be 6 and 6. According to this right now, oxygen has 2 and 4, so it's going to need 4 more. So 6 plus 4 plus 6 is going to be 16, and that gives me a 0. And a 0 means all single bonds. So what I'm going to do is I got single bonds there, and so I just put the needed electrons that I said that I needed. So what I'm going to do, I'm going to come over here and I'm going to go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Easy way to check my work is I have 20 valence electrons right there. I should have 20 in my drawing. So if I look right here, use a magic highlighter, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Boom shakalaka. That's how you do it. When you go to do the total, there's just 2 single bonds, no doubles, no triples, no coordinates. So we're good to go there. Next. So I'm going to go here. SIFHF3. So when I go to do it, I total the electrons. Si has 4, hydrogen has 1, and then 7 plus 7 plus 7 for all the fluorines. I'm going to end up with 26 valence electrons. I'm going to go Si in the middle. I'm going to connect them all with the skeleton structure. So I connect H, F, another F, another F. How many did I use? I used 8, 2, 4, 6, 8. So 26 minus 8 is going to give me 18 remaining electrons. Then I go to do needed. Hydrogen never needs any, so I know that's 0. Outside is going to be 6, 6, and 6. Inside, if I look, it has 2, 4, 6, 8. It's done. It needs 0. So I just need 6 plus 6 plus 6 is 18. 18 minus 18 is going to be 0. So it's going to be 0 there. So my structure is complete. All I have to do is rock the dots. So I'm at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. When I convert this over to its structural, all I do is just go SI. I just turn the dots into lines like that. And then I would just add all the dots around it. And I can check my work. Whoops. I can check my work by counting all the dots should equal 26. Dots and lines equal 26. And that's a Lewis structure for that. When I do the total, this has 4 single bonds, no doubles, no triples, no coordinates. So for the next one, CH3O minus, since it has a charge, I know I can't have any coordinate bonds. That's the first thing I want to think about. And then carbon has 4 valence electrons, hydrogen has 3, plus 6, plus 1. Why the 1? Because the negative charge means it gained 1 electron. So I'm going to get a total of 14 valence electrons when I start. Then I draw the skeleton structure. So I'm going to go C with an H, H, and an H, and an O. I'm going to go dot, 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 dot. They all have to have single bonds to start. How many did I use? 8. So 14 minus 8, I have 6 remaining electrons. Then I got to go find needed. Well, hydrogen's always going to be 0. Oxygen, if I look right now, oxygen, if you look at it, just zoom in on it right here. Just look at oxygen as it stands right now, only has 2. So the outside one's always going to need 6. Well, let's check the middle one. I'm going to do the magic pen. Watch this. So this. If I just focus on carbon, if I look at carbon, carbon has 8 because it's 2, 4, 6, 8, so it's good to go. So it's 0 for carbon, so I just need 6 electrons. I need 6. I have 6. 0, it's all single bonds. Last step is rock the dots. Now, you notice oxygen's on the outside. If oxygen has all 6 dots, that would mean the electrons came from, all from carbon in that case. Oh, no, wait, no, it can't be. It doesn't have it. Wait. Rewind that. It has a charge, so we don't look for coordinates. If it has a charge, you can't verify where the electrons came from. My bad. Pretend like I didn't just say that. Rewind. Erased. Hold on. Pretend like it didn't happen. Pretend like it didn't happen. Pretend like it didn't happen. And it didn't. There we go. There's your overall structure. You have 4 single bonds, and there you go. No doubles. Bam. Next one, Pi5. Remember phosphorus, the prosperous, or whatever it's called, can bond on all 5 sides. It can have 10. So as soon as you see phosphorus with 5 atoms, you know it's just going to go P. Oops. Do this. We'll do it from the start. Phosphorus has 5. Each iodine has 7. So 7 times 5 is going to be 35 plus 5. I start with 40 valence electrons. I go P, and then I'm going to add I. I use a total of 10. So 40 minus 10 is going to be 30 remaining electrons. Now I know phosphorus is good because whenever it has more than, it can't have any more, it already has more than 8, so it's good. Outside is going to be 6, 6, 6, 6, and 6. 5 times 6 is going to be 30. So then what you're going to get is you're going to get all single bonds. So I rock the dots. Rock the dots, and I'm good to go. That is my structure. It's going to be 5 single bonds, no doubles, no triples, no coordinates. And what I'm going to end up with is when I convert it to a Lewis structure, I just change those to lines, and there I go, ready to go. On the last one was an ion, so technically you're supposed to put brackets and write the charge on the outside. So it would be brackets minus 1. Might be. That one's done. Next one, NO2 minus. We know it has a charge, so it can't have any coordinate bonds. Nitrogen has 5 electrons. Oxygen is 6 and 6 plus 1 because of the minus 1 right there. So when I go to total it up, I get 12, 13 plus 5 is 18 valence electrons. So when I go to draw this sucker, I go NO. Dot, 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 dot. What's 4 minus 18? 14 remaining. Then I go needed. Well, based on what's drawn right now, oxygen only has 2. Outside's always going to be 6. That only has 2. Outside's going to be 6. If we look right now, according to these 2 and these 2, nitrogen has 4, so it needs 4 more. So 6 plus 4 plus 6 is 16. What's 16 minus 14? Or 14 minus 16 is going to be negative 2. Negative 2 equals 1 double bond. So where do I put the double bond? I could put it in either place. It doesn't really matter. It's my choice. So I'm going to put a double bond here. Put that a double bond. Now when I go to add the electrons, I have to be conscious of the numbers changed. So if I look here, this oxygen now has 4. So I add 5, 6, 7, 8. Come over here. This oxygen needs 6. And this has 2, 4, 6. 2 more. 8, you're good. You draw a bracket around it, and it's minus 1, and there you go. When you go to turn it into a Lewis structure, I guess you just do a Lewis structure for this one. You do that. Minus 2 always means 1 double bond. Make sure everybody has 8. Next one, BH3. BH3 is a unique molecule. Boron only bonds on 3 sides. It can only handle 6 electrons. So keep that in mind before you even start. So if I go 3 for boron, that's how many valence electrons it has, and there's 3 hydrogens, there's a total of 6 electrons. So when I go to do this, I'm going to basically go, okay, B is going to be my central atom, H, and H, dot, 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 dot. So how many did I use? 6. As soon as I hit 0, my structure is done. Single bond, single bond, single bond, done. So this molecule has 3 single bonds, and it's good to go. Same thing if you're going to do like BCl3. If you notice, if you go, you're basically going to add a Cl on either side. Cl, 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 and then in the end, since it can only single bond, you basically just rock the dots. They're all going to have 6 on the outside because boron is an exception to the octet rule. So the other ones will have to have 6 because they're only getting 2 from there. It's an easy thing to remember for boron. Next one, SCl6. Remember sulfur Superman? Sulfur is one of the exceptions. So if you look right there, first thing is sulfur has 6 valence electrons. Chlorine has 7, and there's 6 of them. So 7 times 6 is going to be 42, plus 6 is going to be 48 valence electrons. And I'm going to go 6, Cl, 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 Cl. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You connect every molecule with a single bond, which is 2 electrons. So I subtract 12. 48 minus 12 is going to be 36. Then I go to do needed. This is an expanded octet, so the middle one doesn't need any. Outside's always going to be 6, unless it's hydrogen. 6 times plus 6 plus 6 plus 6 plus 6 is 36 equals 0. All single bonds, so I add the dots. I add all the dots there, I'm good to go. And then what I do is, to do the Lewis structure, I just change these to lines. It's the same thing as 2 dots. And there you go. It has 6 single bonds, no doubles, no triples, no coordinates. Next, 9. 9 is an ion, so if we look right here, I know it can't have any coordinate bonds to it. So I'm going to go Cl has 7 valence electrons, oxygen has 6 plus 6, and then negative 1. So I'm going to add one more, so it's going to be basically 20 total. 20 total valence electrons. So I'm going to go Cl, line up, dots, O and O. I just used 4, so I'm going to be left with 16, right? So I have 16 left over. When I go to do needed, 6 on the outside, 6 on the outside. Chlorine has how many? So then I need 4 more since it has 4. 6 plus 4 plus 6 is going to be 16. 0. What does that mean? All single bonds. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 added. 1, 2, 3, 4, 5, 6. Bracket the sucker because it's an ion. Minus 1. This changes to a line in the Lewis structure, and you are good to go. Boom shakalaka. It has 2 single bonds, and that is it. All right, I go to do this one. The first thing I notice is I got oxygen on the outside. Alert, alert, alert. That pretty much means that you could have a coordinate bond. I'll show you an easy way to check that. So what I'm going to do is selenium has 6. Oxygen has 6, 6, and 6 for a total of 24 valence electrons. So I go Se, I go O, 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 1, 2, 3, 4, 5, 6. I just used 6 electrons. 24 minus 6 is going to be 18 remaining electrons. Then what I'm going to do is I am going to figure out how much I need. Outside here is going to be 6, 6, and 6 always, because they only have 2 so far. When I look at the one central atom, that's where I really got to think. It only has 6 right now, so it needs 2 more. So when I total it, I'm going to go 6 plus 6 plus 6 plus 2 is 20. 18 minus 20 is negative 2. That means I have 1 double bond. Where do I put it? I pretty much put it wherever I need to. So what I'm going to do is I'm going to put the double bond, let me clean this up a little bit. I'm going to put the double bond right here. Here's my double bond. Still a single bond, still a single bond. When I look at this, oxygen has, if I look right here, oxygen has 4 right there, so I'm going to add 4 more since it's a double bond. I go to this one, 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5, 6. Then when I look at this one, this has 2, 4, 6, and 8, so it doesn't need any more. So there's my structure. It's drawn. When you go to look for a coordinate covalent, what that means is the bond is getting all of its electrons pretty much from the central atom. If you notice how there's 6 valence electrons on the outside here, that means both electrons had to come from Se. If you notice here, same thing, 2, 4, 6 on oxygen. It had to come from the central atom, so that would technically be a coordinate as well. So this would have 1 double bond and 2 coordinate bonds based on that, especially when you see oxygen, sulfur, or selenium on the outside. That's key candidate for a coordinate covalent bond. Next one, BH2. Well, this is another weirdo, beryllium, psyllium, or whatever it is. Beryllium has 2, H has 1 and 1 for a total of 4 valence electrons. So when you go to draw it, you go BE, H, and an H. So then basically what you do is you have to make a single bond. Notice beryllium only bonds on two sides. It can only handle 4 valence electrons. So I just used 4. 4 minus 4 is 0. Done. Bam. Single bond. Bam. Single bond. You are done. You only have 2 single bonds in that sucker, and that is it. Next one. CH11OH. When you look at this molecule, this is a chain molecule. It's basically an alcohol, so it has OH. What I want to basically get your attention is the 5 carbons. So I'm going to make a chain first. So I'm going to do this. I'm going to go 1 carbon, 2, so there's 3 carbons. Whoops, I'm too excited. 3 carbons, 4, and 5. So the first thing is I make a 5 carbon chain, and then I'm going to add the O and the H to the outside. So I have that. The only thing I have left to do is I have to add 11 H's. So starting with the C right here, I'm going to go add an H, add 2 H's, 3 H's, 4 H's, 5 H's, 6, 7, 8, 9, 10, 11. And magically, I have my molecule. If I think about it, all these hydrogens have what they need, and all the carbons basically have what they need. There's only one thing in an alcohol that doesn't have what it needs, and that's the oxygen. Currently, oxygen only has 4. Add 4 more, and you're good to go. So whenever you see a chain of carbons, make the chain first. If it has an OH, you add the O or the H to it. If they gave you something like, let's see here, if it was, let's see, C2, I don't know, C2 Cl4, let's say, you would go carbon, link the carbons, link 1 Cl, another Cl, another Cl, another Cl, and that point, and you do the same thing, you do the math. So carbon has 4, plus 4 is going to be 8, plus 7 times 4 from chlorine is going to be plus 28, so it's going to be what, 36? So 36 valence electrons to start out with. I use 2, 4, 6, 8, 10. 36 minus 10 is 26. I have 26 left. If I look here, 6, 6, and 6, and 6 always on the outside. This one so far has 2, 4, 6, so it needs 2 more. Same thing with this, needs 2 more. So I have a total of 28. 26 minus 28 is going to be what? 20, or negative 2, which means 1 double bond. Where should you put the double bond? Where it's going to make the most sense. I would put the double bond in the center there. You just remember, whenever you have a subscript, when you start out, when you have a subscript, make a chain first and then on all the other elements, and that should be good. You should be ready to go for your test. Hopefully this helps. Have a good evening.